I am Dr. Vijaya Gowri, working as Associate Professor in Department of Civil Engineering, B.V. Raju Institute of Technology, Narsapur. The course name is Railways, Airports and Harbour Engineering. Today's topic is corrections for elevation, temperature and gradient for airport. So, the calculation of runway length is very significant in order to safe landing and taking of aircrafts on the runway. So, there is a need to provide proper correct length of the runway for safe movement of operations. So, today we are going to see the runway calculations. Before going to know the corrections for runway calculation, there are some assumptions are made for the runway length calculations. So, the assumptions are airport altitude is at sea level, temperature at airport standard temperature, that is 15 degrees centigrade, runway is leveled along in longitudinal direction, no wind is blowing, aircraft is loaded at its full load capacity, there is no wind towards the destination, en route temperature is standard. So, the basic runway length is for mean sea level elevation having standard atmospheric conditions. There is a necessary to apply the corrections where there is a changes in the elevations and rise in the elevations and temperature and gradient. First we see corrections for elevation. As elevation increases, the air density reduces. This in turn reduces the lift on the wings of the aircraft and the aircraft requires greater ground speed before it going to rise into the air. To achieve the greater speed, longer length of the runway is required. ICAO recommends the basic runway length should be increased at a rate of 7% for every 300 meters rise in elevation above the standard level, that is mean sea level. The rise in airport reference temperature has the same effect of the effect for the elevation, the elevation increase. Airport reference temperature is defined as the monthly mean of average daily temperature TA for the hottest month of the year plus 1/3 of the TA and monthly mean of the maximum daily temperature TM for same month of the year. So, the airport reference temperature is TA plus TM minus TA divided by 3. ICAO recommends that basic length after having been corrected for the elevation should be further increased at a rate of 1% for every 1 degree rise of airport reference temperature above the standard atmospheric temperature at the elevation. The temperature gradient for standard atmosphere from the mean sea level to the altitude is minus 0.0065 degrees centigrade per meter. The temperature gradient becomes 0 at the elevations above the altitude at which the temperature is 15 degrees centigrade. Check for total correction for elevation and temperature. ICAO further recommend that if the total correction for elevation plus temperature exceeds 35% of basic length, there should be correction should be further checked up by the corresponding specific studies at the same site by the model tests. So, the correction of the basic length or increase in basic length should be less than the 35% of the basic length of the runway. Correction for gradient. Steeper gradients results greater consumption of energy and as such longer length of the runway is required to attain the desired ground speed. ICAO does not recommend any specific correction for the gradient, but FAR recommends that runway length after having been corrected for the elevation and temperature should be further increased by at a rate of 20% for every 1% of effective gradient. Effective gradient is defined as the maximum point and highest point and lowest point divided by the total length of the runway. Here we see one example problem. The elevation and airport reference temperature of an airport are 535 meters above the mean sea level and 22.65 degrees centigrade respectively. The length of the runway required for designed aircraft under the standard condition is 2000 meters. Apply the correction required sequence as per ICAO. Find the corrected runway length after applying the temperature correction if the effective runway gradient is 0.3%. Determine the runway length to be provided. Basic runway length have been given is 2000 meters, elevation is 535 meters and airport reference temperature TR is equal to 22.65 degrees centigrade. Effective gradient is 1%. So first we are going to do the altitude correction. So every 7% should be rising for every 300 meters level, 7% need to be applied. But we have 535 meters for above the standard mean sea level. So what is the length? The correction should be done. So 7% of the basic length for 300 meters, 7% for what is the correction for 535 meters. So 535 divided by 300. So altitude correction is, from the calculations we got 249.67 meters. Corrected length, we have to add this value to the basic runway length. So 2000 plus 249.69 is equal to 22.49.67 meters. Temperature correction. So standard temperature at elevation. So temperature at mean sea level, that is 15 degrees centigrade minus, so temperature gradient 0.0065 into elevation. So the elevation is 535 meters. We got standard temperature at elevation level 11.52 at 535 meters level. So temperature correction is runway length into 1 divided by 100 into TR minus STA. For every 1 degree rise in temperature, we need to increase the runway length of 1%. So the temperature correction will be 250.39 meters. So the corrected length is equal to, we have to add after having been applied the correction for elevation, that length we have to consider, that is 2249.67 plus 250.39 is equal to 2500.06 meters. So approximately the corrected runway length after applying the elevation and temperature corrections, that is 2500 meters. So check for correction. The corrected length should be less than the 35% of the basic length. So the corrected length is 500 meters. It is less than the 700. So it is the corrected length is okay. So next, gradient correction. Gradient correction is applied after having been applied the correction for elevation and temperature. The same length has to be taken, that will be the 2500. For every 1% of effective gradient, we need to apply 20% increase in the basic length. So 2500 into 20 divided by 100 into 0.3 is the gradient, percentage of gradient has been given in the problem, that will be the 150 meters. Therefore, corrected length is 2500 plus 150, that will be the 2650. but sometimes it may be happen more than 35%. Here it is less than 2700. So our check is okay, our design is okay. Sometimes it may be more than 2700, that is more than 35%. For example, if we are taking 0.5% is the gradient, then the corrected gradient correction will be the 250 meters. 250 meters. So at that time the total length will be the 2750 meters. Then the correction applied which is greater than 2700. So then at that time we have to fix the total basic length will be the 2700. The same time we need to apply the change in the correction for the gradient, percentage of gradient. For that percentage of gradient will be changed from 0.5%, that will be obtained 2700 divided by 2750 into 0.5. That will be the 0.9%. So we need to apply the gradient, change in the gradient. So like this we have to apply corrections for the basic length, for elevation, temperature and gradient. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.